Is that downward?
Yes.
India.
But it would make too much noise during the lesson. All right, so today we're going to talk about fractions. You're probably wondering why we're talking about fractions. So in my experience, she'll pass it around, this one. In my experience, students generally have a lot of trouble with the math we do in chemistry and the same thing in physics. So at the beginning of the year, I teach you as much math as I think you need to know. So when you come here on the first day of school, I assume you know 4 things: add, subtract, multiply, and divide. And then anything I want you to know after that, I teach to you to make sure that you know it. So, we're going to talk about fractions. Or the part of fractions that matter to me anyway. And if you ever didn't understand fractions, here's your chance to get caught up. All right, so I'm going to do a bunch of examples, and these are going to go kind of quick. So get out your notes, make sure you're ready. I always try to start out with something obvious and then work towards the things that you don't know. So the first one, we'll do something very simple. Here's a fraction. What's this? 1. It's 1, right? 5 divided by 5 is 1. Make sure you understand when we're talking about fractions, they are the same thing as saying this divided by this. That's what a fraction's saying. So even though I'm writing a fraction on the board, I'll be saying divided when I'm talking.
1.
Right. It doesn't matter what the number is, it's going to be 1. Let's take a vote. How many people say 1? How many people say x? It's 1. X divided by x is still 1. Anything divided by itself, except for a 0, which really should be anyway, but we won't talk about that. Anything divided by itself should be 1, whether it's a number or a variable. Because if it's a variable, that means you can just plug in any number, and whatever number you plug in for this one has to be that one also. So same thing, no matter what it is. A divided by A is 1. If it's smiley face divided by smiley face, it's not really smiley, it's like kind of half sad. It's still going to be 1. Whatever it is, it's going to be 1. Same thing happens if we have units. If I put feet over feet, 1, they go away. The units are gone. So we have to be able to divide all of these things. In science, we need units for numbers, right? In math class, you just deal with numbers. Everything's just 3 or 57. But in real life, everything has to have a unit. If I say I ran 5 today, 5 what? 5 meters, 5 miles, 5 kilometers, a big difference there. So all of our stuff needs units, and we need to be able to deal with units and fractions too. All right, we're going to go with this. Let's do this first. Okay, next one, let's do something like this. 6 times. Whenever I put parentheses, that means multiply. I don't use the stupid X or the stupid dot. I do a number next to parentheses, that means multiply. All right. Exactly, right? 6 times 5 divided by 5. Well, it's 6 times 1, basically, so it's going to be 6. All right. About 12, right? 10 over 5 is 2, right? So that's 6 times 2 is 12. Remember, when you multiply a number times a fraction, right? This is 6 times the top. We never multiply times both the top and bottom. I see that mistake sometimes. Students think it's supposed to be multiplied times both of these. It's not. All right. Let's do something like is it 6?
6.
This
Yes,
yeah. Yeah, like I said, you're multiplying the 5 times the top only, right? So if you did it the long way, you'd do 5 times 6 is 30. 30 divided by 5 is 6. But let me write this out for you because I want you to see something here. This is the same as saying this. 5 times 6 over 5, right? Those two are the same thing. That's what this means. It means this. And this can be rewritten this way. Right? So all 3 of those are the same thing. So really this here could be thought of as 5 over 5 times 6. And you can cancel those 5s and see that it's just going to be 6. I know math teachers hate the word cancel, so don't say it to them, but that's what we say in science. All right, so let's do 47 times 8 divided by 47. 8, right? And so you can always either do either one, whichever one cancels easier. If I had 20 times 3 over 5, okay, so for something like this, you know, I could do 20 times 3 first, right? That's a long way. But I could just cancel, you know, like divide one of these first to make it smaller, right? So if it was me, I'd say 20 over 5. That I can do that easily, right? What's 20 over 5? That's 4. 20 over 5 is 4. 4 times 3? 12, right? Now on the other hand, if I had 3 times, I don't know, let's do 15 over 5. Here it's easier to divide this one. This one's hard. 3 over 5 is ugly, but 15 over 5 is easy, right? So what's this? This is 3. 3 times 3 is 9. So you can always divide either one. You obviously don't do both. Or you can do it the long way, right? You can always just multiply the top numbers, get an answer, divide by the bottom number. But then it tends to be harder to do in your head because you're dealing with bigger numbers. All right. Let's deal with a little bit of units here now. What if I gave you 6 feet divided by 2 feet?
3 feet.
How many people say 3 feet? Anybody got anything different? All right, well, you're all wrong. 6 divided by 2 is 3. That's right. But I got feet on top and bottom, so the feet have to cancel. So the answer ends up with no units. It ends up just a 3.
I mean, that's what I meant. It's not 3 feet.
I didn't say that.
You said something different, and 3 feet is different than 3.
Okay. Yes, I didn't hear you. All right, so yeah, the answer is 3. Now, if on the other hand I gave you, let's say 9 feet divided by 3, what's this? 3 feet. This one's going to be 3 feet. There's no feet on the bottom, so they don't cancel, so feet stay up there. So 9 divided by 3 is 3. All right, let's do 16 kilograms times seconds. Yeah, these units show up like this. Whenever we multiply units, I put a little dot over 4 seconds. Yep. Seconds cancel. 16 divided by 4 is 4. 4 kilograms. So get used to the units doing the same thing the numbers and the variables do. You got to cancel units the same way you cancel that other stuff. All right, let's do one more. Let's do 14 times 99 over 7. Times, sorry, not times. Let's put kilograms and meters out here and seconds down here. What are your thoughts here? Yeah, exactly, right? We're not going to do 99 over 7. That'd be messy. I don't know what that is. 14 over 7, that's easy. What's that? That's 2. So we're just going to do 2 times 99, which is what?
And they drop like that, the things?
The units stay. The units are going to still be there, just the numbers. Only the numbers. So 2 times 99 is 198. And then all the units that are there, none of them are canceling here. There's nothing on top and bottom that's the same. So I got kilograms, I got meters, and the seconds are on the bottom, they stay on the bottom. All right, questions?
And you would just leave it like that?
Just like that. No way to simplify it. And I don't want to see people doing this, right? I don't want to see per second with the slash. The reason I don't like this, it is acceptable notation in a textbook, and they do it because it prints easier. But when you have the slash, people tend to confuse it and not understand that they can. When you're doing algebra, you need it down here so you can operate stuff. Don't use the slash. It makes you make mistakes. And I didn't explain that well, but don't use the slash. Always put a horizontal line, put all the stuff on top, all the stuff on the bottom. Keep it like that. Should I do any more examples, or are we good? Good. Good? All right. So here's your worksheet. It should be fairly easy. And Rocco, do that please.